Lesson 1, Day 2, continuing with graphs of the function. First, we need to do warm-up number 2. So we'll turn to the next page. So it says a function shown in this table below. If included in the table, which ordered pair, -4, 1, or 1, -4, would result in a relation that is no longer a function? And explain your answer. Right, so remember, we know that to be a function, each x has to map to only one y. So if this is going to no longer be a function, you should see a repeating x value. Which point would do that? And that's the -4, 1, because it would create repeating x values. Or it would make the x value -4 repeat. Alright, let's go ahead and look at our notes. Lesson 1, Day 2. First thing is completing the table. You know how to do that, so go ahead and pause and get that done. Alright, so this is what your table should look like. And when we get to letter A, it says to plot the ordered pairs from the table. Remembering your input goes with your domain X, and output with the range Y. So those two columns in your table are actually your ordered pairs. This is the point 2, 7. So that looks like negative, so we'll fix that. So these are the points you're going to plot in your graph. You have 2, 7, 3, 9, 4, 11. 5, 13, and so on. So 2, 7, and I know that they're all going up by 2. So I'm 2 over 1. Make sure you're using your ruler to connect those dots. Alright, so now what is the domain of f of x equals 2x plus 3 for 2 less than or equal to x less than or equal to 8? Because they included this, it means you have to stick with the interval. We can't actually do just the plain all real numbers, even though it's a line like before. So it's going to be all real numbers. And then again, because domain goes with x, and we're looking to do this from 2 to 8, checking again off your table, like we could still do anything from 2 to 8. So x will be between 2 and 8. They can also be equal to them. As for the range, we go look at our answers. So again, for that same interval, we have to stick with just this. I can't just say all real numbers. Well, for the range, where do I start and where do I go within this set of x values? We start at 7 and go to 19. So that's what I have to show. It's all real numbers, starting at 7, going to 19. Make sure you say y this time because it's a range. And I'm going to be equal to them. Alright, so that's the only thing that's a little bit different now, is that we are going to restrict the domain and range according to intervals too. So like if it doesn't tell you the interval like it did on these questions, then you would do it exactly as it exists as a whole entire graph. They do give you the interval, you're only looking at this portion. So you have to make sure to restrict. So again, it's table, graph, domain and range. We are back to not having any restriction as far as how we find the domain and range, so I want to do the whole entire thing. Alright, so again, you know how to plug it in. Pause it and then come back. Alright, so this is how it should look. Going ahead to graph, I've got -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. If you haven't already put it in your calculator, you really should take a look. And you see how it's got that curved shape. Can you get a little closer so it looks more like this? Yours should be curved too. You shouldn't have it be pointed. It's a smooth and continuous curve. So that's where we are. Now it's time for the domain and range. So I know the domain is all real numbers. I need to decide, do I need to restrict it? Do I need to cut it down? With this being a cubic function, I know it's continuing forever. Besides going up and down, it is also going out to the left and the right forever, so I don't have any restriction. And for the range, again, we can see it's going up and down forever, no restriction. So with the homework, same process as before. Okay, go through the table, fill it out, do the graph, do the domain and range. Just kind of paying attention to whether or not it's been restricted, and it's not. Like, you're doing the domain and range for the whole entire graph, so look at that carefully. I want you to try this review question, see if you can figure out which one of these is not an equivalent set of equations, which one could not be used to solve that system. And it's another review question. Noticing it says if in this new formula r is equal to, so this is telling you to solve for r. Tells you right here too. So take this formula here, solve for r, see which one it matches up to. Question 4 is a little bit tricky, so we can talk about that in class. There'll be a bonus homework 1 just for doing the best you can on it. So you want to do it, and I'll give you bonus points. And that will be it. So see us if you have questions.